Hello, everyone. On behalf of the awards committee, I want to thank the nominators and John Martin Awards Committee for their efforts on the award. The John H. Martin Award is awarded each year to a publication that has led to fundamental shifts in thinking, research focus, and interpretation of a large body of previous observations. This year's winner is a seminal paper that illustrated the importance of freshwater systems to the global carbon cycle. Previously thought to have a negligible contribution, this publication led to improved quantification of the global surface area and size distribution of inland waters, which was a necessary step in reducing uncertainties in the global carbon budget. Further, this publication has been important in policy as well. It was first cited by the 5th Intergovernmental Panel on Climate Change in 2013 and has been well cited by other policy documents since. Led by the late John Cole, Cole et al., 2007, entitled Plumbing the Global Carbon Cycle, Integrating Inland Waters into the Terrestrial Carbon Budget, published in Ecosystems, is this year's John Martin Award. Nina Caraco, John's partner, has asked that Dr. John Downing accept this award on behalf of all of the co-authors. So please join me in welcoming Dr. John Downing to the stage.
You. Well, okay, obviously, thank you very much, ASLO, and thank you to everyone. And I'm wearing this t-shirt in honor of John Cole, and you might find it odd, but I went through 2 whole meetings with him wearing pretty much this because he kept losing his luggage. And so when I was asked by ASLO to accept this award, I quickly went on eBay to see if I could get one very similar, and I did. So, but what do you think? A new look for me? You think it's all right? All right. Sure beats a tie. Yeah. Anyway, so thanks to everybody. Thanks to the awards committee. Thanks to the nominators, and thanks to this terrific group of people. They did unbelievably great work, and we became friends, and I'll get into that in just a second here. So you may not remember, but back in 2016, John was also principal author on another paper that received the Martin Award. So I thought I'd jump in and ask Kim Wickland and John Cole to give me a little bit of help in kicking off this this presentation. So let's go.
This paper has really stood the test of time and has served as a foundation for a large number of contemporary studies of inland water carbon cycling and their role in regional and global carbon budgets. The paper has been cited almost 600 times and continues to have a high annual rate of citations, further demonstrating the continued influence this paper has in the field. So please join me in congratulating John Cole and his co-authors for receiving the 2016 John H. Martin Award.
What she said. Oh, that's not the. How do I go backwards? Okay, sorry. Yeah, well, I was going to say what she said. She said the whole talk, and thank you. But I will go. I'll do it anyway. And say some other things too. So, okay, can you hear me now? All right, sorry. So this is the actual paper, and I can point out that the award is for the paper, not for the person up here talking. And yeah. So here's the outline.
Thank you, John. Appreciate it. He just kind of had to be here. So what we're gonna do is. Go through how inland waters were seen. We're going to go back in time to when about half of you were probably toddlers, back in about 2002, 2004, when this all kicked off, and talk about how they were seen back then, how inland waters were seen, as Liz indicated, why they were underappreciated, where the team came from. I thought we'd go through the social aspects of this a little bit, and what we didn't know when we started on this work, talk about the origin of the paper, some thoughts on why it was successful, and then maybe where to go from here. And I'm really hoping I have time. Now, is this timer set for 12? That was set for 15, so I've already blown away some of my time. Okay, let's go. So it's appropriate that this presentation would be given, that the award would come from ASLO, because the idea was conceived at the 2002 ASLO meeting in Victoria. We got together at a party, I think, probably in my room. We often did that, and we had nothing. We had scant data. We had few inventories of basically anything in terms of inland waters, only the sense that somebody needed to figure this out. And John kept saying, sure, we're not correct, but are we an order of magnitude off? It's better to have a poorly constrained number than no number at all. We did our best, but frankly, you all did the rest by filling in the gaps and making the science stronger and better. And thank you so very much for doing that. What the paper did, for those of you who don't know this paper, it made one of the first estimates of the global role of inland waters in the global carbon cycle. It found that about 2 times more carbon enters inland waters than flows off the continents into the ocean, and that there's substantial processing by burial and gas evasion to the atmosphere. And we showed that inland waters are an active pipe, not a passive pipe. Just for reference, this is what the global carbon budget looked like back in 2002 when we first started thinking about this. There's a whole bunch of land here, but there's no water on that land, and it basically was ignored. Here's another one. We were somewhat frustrated that inland waters were considered inactive. Right there, okay, inactive, no water on the land. And here's another one. I got tons of these things I won't bore you with anymore. There were just so many of them around, but they all ignored inland waters in the global carbon cycle, which we found to be not a real good idea. Aquatic ecosystems at the time were thought of as either insignificant due to their small spatial extent. They were considered to be pipes, basically, that'd be the rivers and the stream, or they were considered to be slightly leaky basins. So they were really disrespected. That was terrible. This all comes out of cognitive psychology, and it's called the saliency error. It's a fundamental attribution error, and it is big things have big effects, smaller things have smaller effects. And even the wonderful scientist Ramon Margalef in his book Limnology Now made the same fundamental saliency error in assuming that, that inland waters were unimportant in global budgets. I have to show a picture of Tallinn Man because it was one of John Cole's very favorite things, and I'll come to that in just a second. But if you do a little mind experiment with me for a minute, you know, lakes are thought to compose about at the time, about 1.8% of the land surface. If they do things at the same rate as the land, then they're about 1.8% of whatever rate it is you're calculating. If they do things 10 times faster, or more efficiently, then they process things at the same order of magnitude as terrestrial systems. They do things 100 times faster or more efficiently, they could be more important than land. Now, the reason the Tallinn Man is really important for this is a great example of coarse particulate carbon burial buried in a bog in Denmark. And the thought was that the inland waters must, at least in burial or gaseous terms, be really efficient and effective. So now, John Cole always maintained the Tallinn Man looked really a lot like the famous limnologist Martin Sondergaard, right? Well, I'm not 100% sure. I'm not seeing it. But anyway, let's go. Earth is a chocolate chip cookie, and I just want to impress that on you. This was an idea brought forward by John Milak, part of this group. Limnology has shown that inland waters are really active particles that are embedded in a fairly inactive matrix. Rates are typically 100 to 100,000 times faster or more efficient in inland waters than in oceans and lands. And the reason is because they are not as water limited as land, and they're not as nutrient limited as the ocean. So these friends of mine, and with the help of Nina and I, put together a proposal to NCEAS, the National Center for Ecological Analysis and Synthesis, and then we added a team, and there's Yves Perry on your left, and John Cole and Carlos Duarte. A great team of old friends that I'd known for years. Here's the NCEAS ITAC team. This is integrating terrestrial and aquatic carbon cycles, and it consists of, you see me there, very younger me. I actually own that jacket still. Anyway, but there's John Cole, and then Yves Prairie, and John Milak, Pirkko Kotalainen, Lars Tranvik, Jack Middleberg, Carlos in the back, and Bill McDowell and Rob Striegel, a great group of people. The only person not pictured here is Nina Caraco, and this is the only picture I have of her from the 1980s. I stole it from the IES site, but she was often home with the dogs, I think. This is the original, these are original objectives, and I'll make it easier. And we basically said there are gaps in the global carbon cycle because inland waters are ignored and assumed negligible. Inland waters have been found to be important in some regional carbon balances. So this may be true at the global scale, so freshwater systems process a lot of carbon, and the objective was to synthesize as much data as we could find to see if we could get an answer to this question. Well, here's what we knew when we started this. Almost nothing. I mean, it was quite remarkable, this team of people. We didn't know how much of really any inland water system there was in the world, including lakes, streams, rivers, ponds, wetlands, groundwater. We didn't know enough about the rates of greenhouse gas loss or uptake from a variety of ecosystems. We didn't know how much carbon was being sequestered or buried in all those systems, and we didn't know how to upscale to global rates given the uncertainties that there were. We just didn't know a whole lot. Guiding principle actually came from John Cole, but Francis Bacon came up with it earlier. Truth emerges more readily from error than confusion, and John would say, let's get the best numbers we can with the data we have. Let's figure out whether it's likely to be a big number or a small number. If it might be a big number, let's work to constrain and improve it. And it was comforting to have that latitude. There is a history of global upscaling in limnology going back to Hobfass and Tienemann. They were historical fans of global upscaling starting in the early 1900s. Well, we set to work to rough out this carbon budget for inland waters. It was cheap, going to Mike Pace's point that he made a few days ago, that if funding is constrained, then we've got to find inexpensive ways of doing good science. We worked in little depressing rooms at NCEAS in Santa Barbara. The work was fun. We became really good friends, which I think is a lot of this. Everybody pulled their weight, another big piece of it. Everybody did their homework between meetings. And we had so much fun that, in fact, we were disinvited to ever go back to a certain hotel. So the plumbing writing task multiplied into a whole lot more projects, as you can imagine, and probably some of you may have even seen some of them. So this is the origin of the paper. The paper we started working on it right away in 2004 because we knew we had to do this and we didn't have much to fill in there. And Yves Prairie drafted it the first round for Frontiers in Ecology in 2004. And you see a copy of it I can't believe I was able to find. And then John Cole picked it up like a year later, and Rob Striegel and Lars Tranvik put tons and tons of work into it and sent it out to us all for input. It was submitted to Ecosystems in 2006 and accepted in 2007. And the now famous figure, I've seen it several times at this meeting, I drafted it on a piece of newsprint with a permanent marker. And oops, that's the paper. And there it is. That's the original of the graph. I folded it up and stuck it in a folder. And it isn't really much different from the one on the right. We put some numbers on it and stuff, but it looked pretty much the same. I took out the stick man and stuff. But and even the equations are about the same. So, but we knew where we needed to get. We just needed to fill in the blanks. It has been now cited 4,400 times, which is stunning to me. But before I talk about that, I'd like to say that each one of the authors picked up their piece of it, and we published about 180 or more papers following up on that work, and they've been cited 26,000 times since then. And you can see the averages. I don't need to read them. This is from Web of Science, and it's the top number there is about 280, 300 per year in citations, and I thank you all for doing that. That's a real pleasure. Here's why I think this work succeeded, and I think this is an important part. We chose to try to do something that we didn't have all the data for, that we wanted, and we tried to create a niche really with this model where normal science in the kind of Kuhnian sense could take over, explicitly imperfect, that we left space for others. Team was composed of people familiar with the elements, maybe not the world experts, but we were reliable and we were committed to trying, and we were compatible, and for the most part, egotism was pretty much left at the door. You know, where to next? You know, just on the left, I'd like to encourage you all, it's not just a bigger number, but a better one that we're looking for, bigger numbers, it's not just bigger ones, but better ones. We need to understand why bottom-up and top-down numbers don't agree. We need more realistic upscaling, considering multiple covariates, and we need to map these probability density functions of driving those key rates. And we need to upscale beyond carbon. Inland waters are still ignored in global budgets, including energy radiation, the water budget of the planet, oxygen budget, nitrogen, phosphorus, silicon, sulfur, you name it, and biodiversity and a number of other biotic factors. So this is what the current global carbon cycle looks like according to the IPCC. And it's in part thanks to this paper, in part thanks to this great team of people. It got integrated because of great people like Kim Wickland working at that science policy interface with the IPCC. And that's my little dog there. Anyway, and just to close out here, I just want to
So I'll end there with
bring John in.
couple of pictures of people who've worked on this but weren't part of that paper. This is Mike Pace manipulating a lake, Steve Carpenter doing some modeling, and the NC's group who's responsible for that plumbing paper doing some synthesizing. You'll notice that what that says on the canopy is Wetzel's Pretzels, a place in Santa Barbara. So I'll end there.
And I'll end there too, and just say thank you. It looks like I had 1 second for questions, so I better leave. Thank you all so very much.